Alright, getting started today on 13.1, right triangle trigonometry, day 4. And for day 4, we take a look at a special right triangle. So the numbers 30, 60, 90 refer to the angle measures, and because 90 makes it a right triangle, and then because of the balance of a 30, a 60, the way one angle is twice as big as the other one, this is a very common right triangle that of all the possible measurements, of course these other two numbers have to add up to 90 themselves, but that means you could have 70 and 20 and all sorts of possible combinations there, but you're not going to find them as useful or as popular in constructing things as you will a 30, 60, 90. And because all of this trigonometry is based upon ratios and the way that proportionally they stay the same as each other, that means that in any 30, 60, 90 right triangle, we know the ratio of the sides. That when reduced to simplest form, the ratios are 1 to radical 3 to 2. And notice it all depends on where the side is in relation to the angles. So the hypotenuse across from the right angle is the biggest one, and that's got a measurement of 2. Across from the 30-degree angle is the smallest one with a measurement of 1. The measurement across from 30 is always half as big as the hypotenuse is. And then across from 60, you end up with an irrational number there. This fits if you check it with Pythagorean theorem, and you'll find that across from the 60 is a radical 3, which is approximately 1.7. So what this allows us to do is take any 30, 60, 90 right triangle and find their sides if we compare it back to this classic one. So, for example, here's another 30, 60, 90 right triangle. And you can see I've drawn it in a different way, but you can locate where the right angle is. You can locate where I labeled a 30. Of course, that leaves this one right here, must be 60. You can go ahead and fill that in if you want. And we want to find the values of x and y. We want to find two sides. If we know one, can we find the other two? So first, I just want to talk about how this compares very nicely with the classic 1 to radical 3 to 2. Notice that the side we know, 8, is across from the right angle. It's the hypotenuse. And in the classic, we know the hypotenuse is supposed to be 2. So when I see that our hypotenuse is 8, I can immediately figure out that our triangle is 4 times bigger than this one. If this is supposed to be a 2, and we see an 8, it's 4 times bigger. Well, proportionally, that means all of the sides are 4 times bigger. So right away, across from the 30, where there should be a 1, well, then I go across from the 30, and it's going to be 4 times bigger. I'm pretty sure the value of y is going to be 4. And across from the 60, where it should be a radical 3, well, across from the 60, where the letter x is, it's going to be 4 times that amount. And the easiest way to write that is just 4 radical 3, unless you estimate using a decimal value. But otherwise, it's just going to be 4 radical 3 right there. Now, that worked out real easy, and those are the answers there. But that's only because 2 and 8 were such nice numbers. So what I also want to show you with the rest of the work here is what if they weren't? What if one of these numbers, what if this right here, for instance, was a radical? The idea that you're just going to look at the number 2 and go, oh, it's this many times bigger, that's not always going to work out so nice. So the other way to do this problem in a little more detail is using proportions. And basically, we're going to make a comparison of things we know, starting with the 2 compares with 8. So that's 2 compares with 8. Now that was from the classic compared to our actual triangle. And I'm going to pick a side to solve for. Let's do x first just because. And so if I went 2 compares to 8, then I go whatever side matches up with x. Now remember, it's across from the 60. So I go across from the 60, and it's the radical 3. So if 2 compares with 8, then radical 3 compares with x. And set them equal to each other. This is a proportion. This is how you've solved similar triangles in years past. You can now solve this proportion using cross multiplication. 2 times x is 2x. 8 times radical 3 is just written as 8 radical 3. And solve for x by doing a divide by 2 on both sides. 8 divided by 2 simplifies to 4. The radical 3 sticks around. And there's that 4 radical 3. Sorry, I realized I wasn't on screen there. There's that 4 radical 3. So to see those steps again, there's the cross multiplication, 2 times x, 8 times radical 3, and then divide by 2 on both sides. And that's what I predicted earlier when I said everything was 4 times bigger. But here's how I could actually show the work even if the numbers were messier. So now that I've got x, I'm going to do the exact same thing for y. And again, I want to go back to a comparison that I know. I'm going to make the same 2 compares with 8. And now I want but what compares with y. And again, that's going from the classic to the new one. So 2 to 8, something to y. Well, y is across from 30, and across from 30 is where the number 1 should be. So 2 compares with 8 the same way that 1 compares with y. And then I can go ahead and solve this one, cross multiply, so I get 2y equals 8 times 1 is just 8. Then divide by 2 on both sides, and y equals 4. So as predicted, it was 4 times bigger. So that's it. That's a special right triangle, the 30, 60, 90 special right triangle. And you're going to practice a couple of those now on page 856, numbers 17 and 19. Thank you.